2018 Leaving Cert Higher Level, Paper 2, Question 6 was Theorem 12 and is similar to triangle question. They state the theorem always. Let a triangle ABC be a triangle. Prove that if a line L is parallel to BC and cuts AB in the ratio S to T, where S and T are now elements of natural numbers, then it also cuts AC in the same ratio. So let's have a look at the diagram here. We have a triangle ABC and a line is drawn parallel to BC. So let's draw a line L here, parallel to BC. We can call these points D and E, or if you want to differentiate them away from the ABC, you could call them X and Y. Then we write down what we're given. We're given a triangle ABC. And a line, what did we call it? XY, and a line XY parallel to BC, which cuts AB in the ratio S to T. So we'd be asked to prove that AY is going to cut the other side in the same ratio. AY to YC is equal to S to T. Okay, I'll do my diagram up here for construction too. Let's just keep the construction diagram separate. A, B, C. We have our X and our Y. And we're going to write down what we're going to do. We're going to divide AX into equal parts. I think there's 3 there. So divide AX into equal parts. We call them S. So into S equal parts. And XB. Try to do 3 there as well. XB into T equal parts. What we're going to do is we're going to draw through each point. Draw a line that's parallel to BC. So let's do that. So from here, we're going to start our proof. So our proof is, and you guys have probably practiced Theorem 11 already, according to Theorem 11, we know that the parallel lines cut off segments of equal length along the other side. That other side is A to C. So what we do, let's give one of these a length. Let this length here, let each segment be equal to, let's call it the letter K. So we write that, let each of these segments equal K. So how many of them have we got between A and Y? We have 3 of them, so that'll be 3K. Or if the other side we know is S, these are all S. We said we were going to call these T. So we can say then that AY, we'll do it up here, AY is equal to S times K. we can say that YC is equal to T times K. So AY to YC is equal to SK to TK. The K is cancelled. We're left with S to T. And that's our proof. Quadrat demonstrandum. Practice this and make sure you don't get it wrong. Part B of this question, we were given quite a lot of information. Angle CAB is 90, AX is 4, AY is 3. And if this is a right angle, we know straight away, let's put our square root of 3 squared plus 4 squared, so XY is 5. And we're told XY is parallel to BC. These lines are parallel, going this way. And we're told that XZ is parallel to YC. Well, that would make this a parallelogram, so this must be 5 as well. AX to XB is 1 to 2. This AX to XB is 1 to 2. Well, if that's a 4, this would have to be an 8. We've quite a lot of similar angles here. This angle and this angle correspond. Also, this angle and this angle have to be the same, which leaves this third angle up here must be a right angle. Doesn't look like it in my diagram. So we've got similar triangles here. So we're looking for BZ. So let's call that X. So X over the corresponding side in the similar triangle is red dot to blue dot, which is this one, which we got to be 5, is equal to, we started with this triangle, so we got to continue with this one, and we have our 8, our red dot to our right angle, 8 over, and in the other triangle that would be 4. So, well, X has to be 10, doesn't it? 10 over 5 is 8 over 4. X is equal to 10 centimeters. So BZ is equal to 10 centimeters. A pretty straightforward similar triangle type question.